Hello students, we had learned question 6 in our previous session. Now we shall move on to question number 7. A closed cylindrical tank of radius 7 meter and height 3 meter is made from a sheet of metal. How much sheet of metal is required? Here, as per the given question, the radius is 7 meter and the height of the tank is 3 meter. Since we need to find the total sheet of metal required, we need to find out total surface area. For a cylindrical tank, the total surface area is given by 2 pi r into r plus h. Here, we shall take the value of pi as 22 by 7. Radius is 7, so that they get cancelled. R plus h is 7 plus 3. Here 7 will get cancelled. We'll be getting 44 times of 10, which is 440 meters square. Therefore, 440 meters square metal sheet is required. Question number 8. The lateral surface area of a hollow cylinder is 4224 centimeters square. It is cut along its height and formed a rectangular sheet of width 33 centimeter. Find the perimeter of the rectangular sheet. To find the perimeter of a rectangular sheet, we require length and the breadth. Here, the length is to be found. To find the length, we have to make use of this lateral surface area. So as per the given question, the lateral surface area of the hollow cylinder is 4224 centimeters square. And also they have given the width of the cylinder, which is 33 centimeters. Why this 33 centimeter to be considered as height? When we take a cylinder, hollow cylinder, and cut this hollow cylinder along its height, the width becomes the height of the cylinder. So let me take the height of the cylinder as 33 centimeter. Let r be the radius. So we know that the curved surface area is 2 pi rh. Curved surface area is 2 pi rh. This curved surface area is same as the lateral surface area. So let me take this as 4224 centimeters square, which is equal to 2 into 222 upon 7 into the radius is r into 33. Now we can find out the radius. Radius will be equal to 4224 into 7 divided by 44 into 33. When we spread this hollow cylinder, we get a rectangle. This length would become the circumference of the circle. So let me take L as 2 pi r. R is 4224 into 7 divided by 44 into 33. Here 7 will get cancelled. 44 get cancels. We'll be getting L as 4224 divided by 33. When we simplify this, we'll be getting the length as 128 centimeters. Therefore, perimeter is given by 2 times of length plus breadth. So 2 times of 128 plus the breadth is 33. On multiplying, we'll be getting 322 centimeters. This will be the perimeter. Question number 9. A road roller takes 750 complete revolutions to move once over to level a road. Find the area of the road if the diameter of the road roller is 84 centimeter and its length is 1 meter. Here, let me mention the diameter as D, which is 84 centimeter. This implies that the radius will be half of that, 84 by 2, which is 42 centimeters. The length of the road roller is 1 meter, which is nothing but 100 centimeters. This length of the road roller will be same as the height of the cylinder. So we shall make use of the curved surface area formula, which is 2 pi RH. Let's substitute. It will be 2 times of 22 upon 7 multiplied to 42 multiplied to 100. 7 6 times is 42. So 6 multiplied to 22 multiplied to 2 will give us 264. When multiplied with 100, it becomes 26,400 centimeters square. Here, the area covered by the road roller in 750 revolutions to be found. So this is for one revolution. The curved surface area will be same as the area covered in one revolution. Therefore, area covered by road roller in 750 revolutions will be equal to 26,400 centimeters square to be multiplied with 750. On multiplication, it becomes 198,000 centimeters square. Now we shall convert this in terms of meter square. We know that 1 meter square will be equal to 10,000 centimeters square. Therefore, it becomes 1980 square meters. This will be the area covered by the road roller. Let us solve question number 10. A company packages its milk powder in a cylindrical container whose base has a diameter of 14 centimeter and height 20 centimeter. Company places a label around the surface of the container as it's shown in the figure here. If the label is placed 2 centimeters from the top and the bottom, what is the area of the label? Here you need to observe that 2 centimeters is left from the bottom as well as from the top. So the label will be having an height equal to 20 minus plus 2 from the top as well as from the bottom, which is 16 centimeter. Here the radius of this cylindrical container is half of the diameter, which is 7 centimeter. With this radius and the height, we can find out the curved surface area. So the curved surface area of label will be equal to 2 pi RH, which is 2 times of 22 upon 7 we multiplied with 7 times 16. Here 7 get cancels. This will be equal to 44 times of 16. We'll be getting 704 centimeters square. This will be the area covered by the label on that container. With this, we have completed the exercise. Now we shall move on to the next exercise, which is related to volume. Question 1. A cylindrical tank in which situation will you find the surface area and in which situation you will find the volume. There are 3 situations given. The first one is to find how much it can hold. Second one is the number of cement bags required to plaster it. Third one, to find the number of smaller tanks that can be filled with water from it. We find area when the region is covered by the boundary, such as outer and inner surface area of the cylinder, cone, sphere, like that. And the amount of space occupied by an object, such as water, milk, coffee, tea in the containers, we need to find volume of that particular object. Here, the first one is to find how much it can hold. It means that it is related to volume. In the second, the number of cement bags required to plaster it. It means we'll be finding the surface area. Third one, to find the number of smaller tanks that can be filled with water from it. It is again related to capacity, which is nothing but the volume. Second question, the diameter of cylinder A is 7 centimeter and its height is 14 centimeter. The diameter of the cylinder B is 14 centimeter, whereas the height is 7 centimeter. Without doing any calculation, can you suggest whose volume is greater and verify it by finding the volume of both the cylinders? Check whether the cylinder with a greater volume has a greater surface area. So this is a question related to both surface area and the volume. Here, the cylinder with the greater volume will be having greater surface area. It becomes very difficult to guess which one will be having larger volume. I think volume of the second one will be larger because it will be having larger base. Let's try finding out, because the volume formula is pi r square h. Here the thing to be observed is the radius is taken twice. When the radius is just 3.5, that is 7 by 2, when you square it, it will not be that larger when you take 7 into 7. So volume of B will be larger. So let's try finding out volume of cylinder, both cylinder A and cylinder B. So for cylinder A, they have given the radius as 7 by 2 centimeter and the height as 14 centimeter. Now if you use the formula, volume will be equal to pi r square h. 22 upon 7 multiplied to 7 by 2 multiplied to 7 by 2 multiplied to 14. Here one of the 7 can be cancelled. This 2 11 times, 2 7 times, will be having 11 multiplied to 49, which will be 539 centimeter cube. This is volume of the cylinder A. Now for cylinder B, we have the radius as 14 by 2 is 7 centimeter and the height is again 7 centimeter. Here when we use the formula, it will be pi r square becomes 7 into 7. This is multiplied to the height 7. So one of the 7 get cancels. It will be 22 times of 49. In the earlier case it was 11 times of 49. So this will be 1078 centimeter cube. So it's very clear that this will be having, cylinder B will be having the larger volume. Now let's find out the surface area of both the cylinders. So PSA of cylinder A, this will be 2 pi r into r plus h. This will become 2 into 22 upon 7 multiplied to 7 by 2 times of 7 by 2 plus 14. This has to be simplified. When we simplify it, we'll be getting 385 centimeter square. Let's also find out TSA of cylinder B. This will be equal to 2 into 22 upon 7, 2 pi into r. R is 7. R plus h is 7 plus 7. This will become 14. So one of the 7 get cancels here. It will be 44 times of 14. This will become 616 centimeter square. It's very clear that the total surface area of cylinder B will be larger. So here we can conclude that the cylinder with a greater volume will be having greater surface area. So let me mention here, therefore the cylinder with greater volume has greater surface area. I have made it very clear. We shall take the next question. Question number 3. Find the height of a cuboid whose base area is 180 centimeter square and volume is 900 centimeter cube. We all must know that volume is nothing but area of base multiplied to height. Here the volume is given as 900 centimeter cube. This will be equal to area of the base is 180 centimeter square. This is to be multiplied with the height h. In other words, I can also say that volume of a cuboid is given by the formula LBH This L into B is nothing but area of the base. So H is to be found. This will be 900 centimeter cube divided by 180 centimeter square. 0 get cancelled. 18 5 times is 90. So H will become equal to 5 centimeter. This 5 centimeter is the height of the cuboid. With this question, I shall end today's session. I shall take up question 4 onwards in the next session. Thank you.